Hey chat, welcome to the stream. We are back with our new live stream. Let me check whether I am live. Yes, I am live now. Welcome to the stream. We are back with our new live stream. Let me check whether I am live. Yes, I am live now. Welcome to the stream. We are back with our new live stream. Yes, chat is working perfectly now. So yes, we should start with a stream now. Yesterday we were doing the CP-31 900 rated problem, right? So today what I thought is, let's do a problem form due to the previous contest that we missed, right? The second problem. So yes, we should start with a stream now. Yesterday we were doing the CP-31 900 rated problem, right? Yo Panther, welcome to the stream. ಅರೆ ನೀ ಅದು ಗಿಟವಿಂದ ರೆಪೋ ಹೇಳಿದ್ದೆ ಅಲ್ಲೇ ನಾ ಪುಲ್ ಮಾಡೋದು ನೆನಪಾರಿದ್ದೆ ನಾನು ಮಾಡ್ಲೇನೆ ಸ್ಟ್ರೀಮ್ದಾಗ ಏನು ಲೀಕ್ ಆಗಂಗಿಲ್ಲ ಅಲ್ಲ ಯಾವಾರ ನೋಡಾತಂತಡಿ ಮಾಡೇ ಬಿಡ್ತೀನಿ ಏನು ಮಾಡ್ಬೇಕು ಹೇಳಿ ಹಚ್ಚಿರ ಕಮೆಂಟ್ ಹಾಕ ನಾ ನೋಡ್ತೀನಿ ಏನದ ಓಕೆ ಚಾಟ್ ಟುಡೇ ವಾಟ್ ವಿಲ್ ಡೂ ಈಸ್ ವಿ ವಿಲ್ ಅರೆ ಹಾಂ we will solve question from due to from the previous contest that we missed out because we have to cover that also, right? Yes, I was talking about this contest. The second problem we missed out because we have to cover that also, right? Yes, I was. Array, I have to reduce my camera angle. Is it good? Yes, it is good. It is good. Is it good? Yes, it is good. It is good. Yes, chat. Yesterday we no. What I'm doing is we will solve this question now, and then we will try. No, we'll just solve this question today because I have a lot of work from college today. Tomorrow I have a test, right? I have to prepare for that. So we will solve this question and we will move on. Okay, hypercrap and the control panel. Hypercarp. Carp is assembling a control panel for a new spaceship. The panel consists of n signal modules arranged in a row. Each module contains a diode of a certain color, and the color of the ith module is represented by integer AI. Okay. The panel consists of n signal modules arranged in a row. Each module consists a diode. Welcome back. Each module contains a diode of certain color, and the color of ith module is represented by the integer AI. During testing, it turned out that two adjacent modules of the same color may confuse the pilot. Okay. Therefore, Hypercarp wants to keep only some of the modules of the panel so that no two adjacent remaining modules have the same color. Hypercarp is assembling a control panel for a new spaceship. The panel consists of n signal modules arranged in a row. Each module contains a diode of certain color, and the color of ith module is represented by integer AI. Okay, panel consists of n signal modules arranged in a row. Each module contains a diode of certain color, and the color of ith module is represented by integer AI. Okay. During testing, it turned out that two adjacent modules of same color may confuse the pilot. Okay. Therefore, Hypercar wants to keep only some of the modules on the panel so that no two adjacent remaining modules have the same color. Hypercarp may remove any number of modules. After that, the remaining modules are shifted together while preserving their relative order. Okay, Hypercarp may remove any number of modules. After that, remaining modules are shifted together while preserving their relative order. In addition, thanks to backup connection, Hypercarp may swap two adjacent remaining modules at most once. It is not allowed to perform more than one swap or more modules after the swap. Okay, we'll check the input, what is trying to say, and we'll check the output. If they are same colors, we have to swap it. If they are, it turned out that two adjacent modules of a same color may confuse the pilot. Okay, therefore, Hypercarp wants to keep only some of the modules the of the panel so that no two adjacent remaining modules of the same color, okay, may, may remove any number of modules. After that, the remaining modules are shifted together while preserving their relative order. In addition, thanks to a backup connection system, Hypercarp may swap two adjacent remaining modules at most once. Adjacent remaining modules at most once. It is not allowed to perform more than one swap or remove modules after the swap. The first case, there is only one module on the panel, so Hypercarp can keep it. So there are no elements which repeat after each other. 4 4 4 4. So he can keep only one in this. So he can keep every element in that. In the fourth test case, he can keep all the three. He can keep all the three. In the fifth one, he can keep we can keep all the fours if we swap 2 and 1 here or 1 and 2 here. In the fifth one, we can't. Okay. Which test case is the eighth, right? The eighth test case. Hypercarp can remove Hypercarp can remove one of the two modules of color 1. After that, the colors of remaining modules are 1 2 3 3 2 2 1. Okay, where is that? The eighth one, right? If we swap, it will be 1 2 1 1 2 3 1 3 2 1 2 1 2 3. If we swap the fourth and fifth module, the resulting sequence will be Hypercarp contains 7 modules. 7 of them and remove one of it, right? So if we swap this, it will become 1 to 1 3 3, right? So we can, if we can, then after swapping these we can swap these two, we can swap these two, it becomes 1 2 1 2 3 1 3, right? After that we can swap 2 and 1, it becomes 1 3, no, 1 2 3 1 3 2 1 2. Okay, he has swapped here, no problem then. Therefore hypercarp can keep 7 modules. Hypercarp can keep 7 modules. Hypercarp can keep 7 modules. But where did 1 2 3 4 5 6 7 1 2 3, how many elements are present here? Array, let me check it, sir. We have 1 1 2 3 3 2 2 1, right? We will swap it 1 2 1 3 3 2 2 1. This is the first swap. The second swap will be 1 2 3 1, because 3 3 are matching, right? 3 1 3 2 2 1, right? And the third swap will be 1 2 3 1 3. No, we will swap 2 and 3 2 and 1. Now no adjacent element are same, right? So in this, the last element, no adjacent elements are same. So we can keep 1 2 3 4 5 6 7 8, we can keep all 8, right? But in 8th test case, hypercarp can remove one of the first two modules of color 1, one of the first two modules of color 1. After that, the colors of the remaining modules are 1 2 3 3 3 2 2 1. After that, colors of our remaining modules are 1 2 3 3 2 2 1. The colors of remaining modules, the hyper can remove one of the. Let me read the question once again, chat. I'm not getting, like, here, right? Just a second. Just a second. Just a second. Yes, we swapped only one time. What he gave is, it turned out that two adjacent modules of same color may have confused the model. Therefore, hypercarp wants to keep only some of the modules on the panel, so that hypercarp wants to keep only some of the modules of the panel, so that no two adjacent remaining modules have the same color. No two adjacent remaining modules of the same color. I am not getting it, sir. Hypercarp question. It turned out that two adjacent modules of the same color, adjacent remaining modules of the same color. I am not getting it. Hypercarp question. It turned out that two adjacent modules of the same color
adjacent or remaining modules of the
During testing, it turned out that two adjacent modules of the same color may confuse the pilot. Therefore, Hypercar wants to keep Hypercar wants to keep only some of the modules. Hypercar wants to keep only some of the modules, some of the modules on the panel so that no two adjacent remaining modules have the same color. No two adjacent remaining modules have the same color. No two adjacent remaining modules have no two some I'm not getting how to check whether the sum of two adjacent modules are are equal. During testing, it turned out that two adjacent modules of the same color may confuse the pilot. Therefore, Hypercar wants to keep only some of the modules on the panel so that no two adjacent remaining modules have same color. Hypercup want to keep only some of the modules. Summer 5 only I am watching. I don't know bro. समर्थ नहीं है ना समर्थ नहीं है ना ಹೌದಾ ನಾ ಕಮೆಂಟ್ ಹಾಕ್ಯಾರ I don't know. By the way, welcome to the stream. ಸಮರ್ಥ 5 ಅಂತ ಇದೆ ಸರ್. After that, it is boring shit, right? Nobody watches it. That's why only you are watching. It turned out that two adjacent modules of the same color may confuse the pilot. So, the hypercar wants to keep only some of the modules on the panel so that no two adjacent remaining modules have the same color. Hypercar may remove any number of modules. After that, remaining modules are shifted together while preserving their relative order. In addition, Hypercar may remove any number of modules. After that, the remaining modules are shifted together while preserving. Hypercar may remove any number of modules. After that, the remaining modules are may remove any number of modules. Sorry, let me focus on this problem. Okay. During testing, it turned out. I want to read this question once again because I am not getting it properly. Okay. Hypercarp is assembling a control panel for new spaceship. The panel consists of N signal modules arranged in a row. N signals arranged in a row. Now, each module contains a diode of a certain color, and the color of ith module is represented by integer AI. During testing, it turned out that adjacent modules of the same color may confuse the pilot. Therefore, Hypercar wants to keep only some of the modules on the panel so that no two adjacent remaining modules have the same color. Okay. Hypercar may remove any number of modules. After that, the remaining modules are shifted together while preserving their relative order. In addition, I this line I did not understand this line. Hypercarp may remove any number of modules. After that, the remaining modules are shifted together while preserving their relative order. In addition, thanks to a backup connection system, Hypercarp may swap two adjacent remaining modules at most once. It is not allowed to perform more than one swap or remove modules after the swap. Determine the maximum number of modules Hypercan can keep on the panel so that no two adjacent modules have the same color. Okay. Now we don't want any two numbers beside each other which are same. Now what we'll do, if it is present, we will swap it. No, what we'll do is we'll just count it, right? Uh, we'll count this and this. If it is odd, then these numbers are, the count is 2 and the number is 2. We can keep it. Uh, how can do is the fourth one. Or okay, 4 minus 1 2 2 3 3 1 1 1 2 3 3 2 2 1. ಮಾಡಿದೆ ಬಂಟಿ ನೀನು ಮ್ಯಾಥ್ಸ್ ಅದೇ ಸಬ್ಮಿಟ್ ಮಾಡ್ತೀನಿ ನಾಳೆ. ಹಾ ತಗೊಂತಾನವ ಅವ ಶಾರ್ಟ್ ಪೇಪರ್ ಇದ್ರ ಬರ್ದಾನೆ. ಅದೇನೋ ಪೇಪರ್ದಾಗ ಬರೆದು ಕೊಡ್ಬೇಕಂತಲ್ಲ. ಅದೇನೋ ಮೊಂಟಿ ಪೇಪರ್ದಾಗ ಬರೆದು ಕೊಡ್ಬೇಕಂತಲ್ಲ. ಹಾ 1 2 1 3 1 2. No, nobody will repeat itself, right? Now we can swap it and then count it. Then there should be a formula for writing it, right? We'll count a number of ones. We'll take a number and take a frequency of it, and then take a frequency of it. Now if we have, let's take here, the frequency of 1 is 2 and the frequency of 2 is 2. If both the frequency, if the total frequency is equals to, how many numbers are there? One two two one, 1 2 2 1. The frequency of 1 is 2 and the frequency of 2 is, let me check. Now the frequency of 1 is 2, chat, and frequency of 2 is 2, right? So the formula that we can create here is 2 minus 2 is 0. So we can create it. Even if what if there was, instead of this is 1 and 3 is 1, so it would be 1 2 3 1. So no two elements are adjacent, right? So we can just keep all the four elements as it is, no need to swap it in this. But uh, if the total frequency is 4 for this, right, but the number of elements present here is 3, the number of elements present here is 3. What if uh, what if 1 2 3 4, right? We can't do anything for this, but 1 1 2 1 1, the frequency of 1 is 4 and frequency of 2 is 1, right? So what we have to do for this is uh, we have to take uh, 4 minus 1 is 3, and no, 4 plus 1 is 5, frequency will be 5. There is no pattern for this. No, there is a pattern where I am not recognizing it properly. Let's take this. We can keep every in the third test case. We can keep every no. We can keep only one element because adjacent elements are same, right? But chat, coming to the same problem, like 1 1 2 3 3 2 2 1, right? So the one frequency is 3, two frequency is 3, and 3 frequency is 2. The total number here becomes, total frequency will be 8, right? Now we can keep all the elements in such a way that no elements is adjacent to same, same element is adjacent to each other, but the answer that they are telling is 7. But we can keep all the 8 elements without being same in their adjacent side. So what, how? Okay, chat, I think I have to ask Gemini now. I have to ask Gemini because how, what is the approach to solve this? Otherwise, I would end up taking 1 or 2 hour here.
The same.
Okay, chat. I think I have to ask Gemini now. I have to ask Gemini because how, what is the approach to solve this? Otherwise, I would end up taking one. Did I take a screenshot of this? So as to find the maximum size of valid sequence, we can keep such that no two adjacent elements have the same color, given that we can remove any number of elements. We compresses the remaining sequence without changing relative order. Swap at most one adjacent pair at the end. Greedy compression. Swap anything where no two adjacent elements have same color. It is cannot stay adjacent. We just keep the first element of every contiguous block of the identical colors. So we condense adjacent duplicates into a single element. For example, 1 2 2 3 3 1 greedily keeping a non-repeating elements gives 1 2 3 1. So yes, elements which compresses the remaining sequence without changing a relative order means and maximum size of a valid sequence we can keep such that no two adjacent elements have same color. Given what we can remove any number of elements which compresses the remaining sequence without changing the relative order. Swap at most one adjacent pair at the end. Greedy compression first. If we don't swap anything, what is the maximum length sequence where no two adjacent elements have the same color? Remove any number. Right. Then I have to ask it what the question is actually trying to say. Then what is the question? On the real story behind the problem. Okay. You imagine you have a row of colored lights. Two lights of the same color cannot sit next to each other. They confuse the pilot. You want to keep as many lights as possible on the panel. You have two powers. You can you can remove any lights you want. The remaining lights slide together to fill the gap, preserving their left to right. You can remove any lights you want. The remaining lights slide together to fill the gaps. Slides slide together, fill the gaps, preserving their left to right order. Remaining lights slide together to fill the gaps. Slide together to fill the gaps. Okay, preserving their left to right order. Okay. Swap at most once after you finish removing lights. Okay, we can swap one pair of adjacent light at most once. After removing lights, we can swap only one time. Now I got it. You can keep every element. You can keep only one element. We can just swap once at most once, right? We can swap only once. Okay. Now we can swap only once or delete once. Okay. This one. Okay, we can swap and keep the maximum. What is the maximum time? What is the maximum lights that we can keep is what is asking, right? So before swapping it, so uh, before removing it, we have to think whether we can keep it as without removing the element just by swapping it. So if we even we swap it, it becomes we have to remove one element, right? Remove one element. No, we have to remove two elements. We have to remove two elements at most once, right? We have to remove. If the frequency is more, If the frequency is more, then we have to remove it. Okay, chat. First we will swap it. First we will swap it and delete all the elements that repeat themselves. Okay. Now we got it. Now I got it. No, chat. We can't do this because if I remove this one, now I can arrange it, right? One, two, three, two, two, three, two, one, right? I can keep it, but how can I do that? So this is the so I got to know what the question is trying to say. We can I'll remove just one from the first index, and then swap 2 and 3 from swap 2 and 3 from third and fourth index. By that we'll get the desired output, which is 7 here. Yes, it is 7. Now we have to check how we should solve it, because we got to know what the question is trying to say, but what the question is trying to say, but we have to we have to uh, we have to check how we should come up with the solution for this. If we delete this or delete this, okay, what we will do is we will first delete the first repeating number, and then swap the first element or the middle element which it is repeating itself, so that we can get our desired output. But we will not get the desired output if we do this here. 1 and 1, right? What we'll do is mm, first I will remove this. So I think we can get multiple outputs. We can get, no, I mean the multiple multiple arrays as the output, not the this one. Okay, we'll see. We got it, right? Okay, false. True. Has duplicates equals false. Now we are checking calculate the greedy length without swapping. Okay, if a index I is not equals, if a index I is not equals, index I minus 1 means the index that is present at this first and the last. You are checking end to end, right, from start and the end. They are coming like this: k plus plus else has duplicates equals true, has duplicates equals true. Array then if there is, if the index is not at index I minus 1 means if the index is 1 and the index is 1 minus 1 is 1 minus 1 is 0, then the previous and the is we are checking if all both the elements array. What did I say 5 minutes back, chat? We are going like this. No, we are not going like this. We are going checking the previous and the present element like this. Index I is not equals to index I, then k plus plus, and if they are equals then their duplicates are present and has distinct colors. Check if array are at least two distinct colors in a whole array. Distinct color in the whole array. As distinct color false, array index I not equals array index 0 has distinct color true, break it. Okay, now what is checking? Has duplicates, has duplicates and has distinct colors, then k plus 1. How? K plus 1 will be the output, else k will be the output. For this, for this 1 1 2 3 3 2 2 1, right? So 1 and 1 are equal, will not increase k by 1. Okay, then for 2 and 3, 2 and 3 uh, k will increase by 1, so k equals 1. Now k equals 2 because it was previously 1, right? Now k equals 2. Then for 3 and 3 it will not increase, 3 and 3 and 2 it will increase, so k equals 3 now. Again for 2 and 1 k equals 4, k equals 4. uh, 1 2, are chat, for 1 and 2 also k will increase, right? For 1 and 2 k equals 5, right? And also for 2 3 4, okay, k will be 5 now. Yes, k will be 5 now. Else has duplicates equals true. Now the k carrying is here 5. It has duplicates and distinct color. Yes, it has distinct color because it has more than, right. Now k equals 5. If it has distinct color, then we have to print plus 1. It will be 6. But how we are getting our output as 7? 1. I 1, 2, 2, 3, 4. So it will be 5 and it will be 6. But wait, I'll check. I'll ask for this. How is k 7 whereas I am getting 6 for it? It's presenting 0. Okay. Equals 1. Okay. Equals 1, 1, 1. False. False. Okay. Is 1, 2, 3, 4, 5. K equals 5. Why the final output is 6 and how you get 7? Greedy length without swap is 5. With swap, since has duplicates equals 2 and as true, we add plus 1, it would be 6. Now where did 7 come from? In screenshot, okay, is 6. If someone told you k equals 7 or output is 7, they might be confusing the test case with a different 6 element. One one, 2, 3 3, 2 2 1, right? Here you go. It's showing 7 as output for the input I gave.
and one or two are here. So same. Okay, chat. I think I have to ask Gemini now. I have to ask Gemini because what is the approach to solve this? And one or two are here.
Full example of page makes everything okay. Now okay. Correct generally, if the array already has adjacent duplicates, answer equals n. If we can duplicate conflicts by dropping one element plus one swap, the answer will be n minus 1. Otherwise, we drop. So, okay, what will be the code for it? Okay, different not just k plus plus. If it is not k plus plus, has a distinct color, see out one and return. Distinct colors are not there, then just print one and return. And if answer minimum of n k plus 2, minimum of one swap can add up to 2 plus elements to the compressed list. Okay, now we got it. Previously it was telling plus 1 would increase for the array length that was given. Now it is telling plus 2 will be increased for one swap elements to the compressed length k. So in the minimum of this, k plus 2 will give the answer. Int answer equals to 8 is the answer. 8 is the given input, and k plus 2 means the k will be 5, then the k plus 2 will be 7. N is 8 and the compressed array will be 5. Now distinct colors is true, and for min of 5 plus 2 is 7 and 7, so the output will be 7. Okay, let's look at the compressor. Okay, it will be on the then 5. We will have to adjacent equal element in a, like, okay, notice that without any happy, identical elements can only contribute one element to the final sequence. With one swap, we can take block of duplicate and insert a different element y without between them to form x to x. This allows us to keep an extra x. Can you single swap all allow us to keep more than one extra element? Yes, if we have multiple duplicate blocks. Okay, a single swap of two adjacent elements can break apart up to two duplicate pairs at once, or allow us to save up to two extra elements. Happens right at the boundary between two adjacent duplicate blocks. Okay, for swapping it, there are at least two pairs of adjacent duplicates. So k equals n if there is no adjacent, if there are no adjacent elements. So k would absolutely be n if there are no repetitions. And if k equals n minus 1, if there is only one pair of adjacent duplicate, if there are more than two adjacent duplicates, then k would be n minus 2, or less than n minus 2. A single swap can save up to two extra elements beyond the base compressed length k. Answer equals min of n comma k plus 2, provided there are distance. Okay, we will check if there is no repetition. I mean, if there is no repetition, then then the k would directly be n, and if there is only one pair adjacent, then it would be k of n minus 1, k n minus 2. Then we have to print k of min of n minus 1. So the code for this would be, Okay, this is what he is uh, just a minute, chat, just a minute. Now we will be taking our input. Okay, we are taking our input perfectly. Now, this if our n means our b equals 1, we can just see out 1, right? We can just see out, and yes, okay. Now we will take int k equals 1, and also for checking if there is no repetition, for int j equals 1 comma j less than b j plus plus, if array index j not equals array index j minus 1, then k plus plus. Okay, we got our length of, no, I mean the number of elements which are not same with their adjacent element, and uh, saving it as k by increasing its frequency by 1. Then we will check whether there are more than, at least, no, not more than, only two colors, or at least two or more than two colors, because if there is only one color, then the answer would actually be just one, not more than one. So if we expect answer more than one, then we need to have more than two or two elements. So what we'll do, we will check has more color. Okay, is first, we have to check it, right? uh, Equals 1, and if if array index j not equals array index 0, then has more color true equals true, then we will break it. Now if uh, has using color is true, what is saying, right? Not has using color means, if it is true, if has more color is false, and it is true that it is false, then we will print it as cout 1 and endl. Okay, this was our code, and now we will take answer as min of b comma k plus 2, because we are deleting and then we are swapping it, right? Why did I add this? Now we can just see out answer that uh, Endel. We are not getting the min function. Why? Array, it's that problem. Okay, we have to write it as int. Okay, let's chat. We got it. We'll test our code. 1 1 2 3 3 2 2 1. So yes, we are getting our output. 2253B, right? This should work. This should work actually. Array, what wrong in this? We are getting the first element as 1 and the second as vector, right? Now the sixth one is, wait, let me check. Array, you should run 12 loops, right? You should actually run 12 loops, but I have to remove these breaks way. Okay, now I think it will work, chat. Just because I wrote there, Urre bhaiya. I have to fix the code where I have did wrong. Instead of continue. Okay, okay, okay. That's the thing that we did.